Don't know, ma'am.
Okay, then we'll start. Okay, it is already 5:05. We'll start. We'll see. They will join later. Okay. So last class we had discussed about some of the terms, right? We had discussed about atoms, molecules, elements, right? So these were the yes. So atoms, then molecules, right? What are homoatomic molecules, right? What do you mean by heteroatomic molecules? Homo means homoatomic molecules means they are made up of same atoms. Okay, same atoms. So they make up a molecule. Hetero means what? Different atoms. Okay, different atoms. So they make a molecule. So heteroatomic molecules. Then we have discussed about atomicity, right? Then we have discussed about elements. What are elements? What are compounds, right? So these were some of the examples. Then we had discussed about structure of atom. Okay, what are neutrons? What are proton? What is electron? What is nucleons? Okay, what are the different shells? What are the subshells? Okay, what is orbit? Okay, then we had discussed about the electronic configuration of first 20 elements, right? So these are the different shells. So K, L, M shell, right? Then, so valency, what is valency? What are valence electrons? Okay. What are ions? How ions are obtained? So when a neutral atom, when there is loss of electron, so it results into cation. When there is gain of electron, then there is a what it is called as anion. Okay. So based on that polyatomic ions, then we had discussed about the chemical formula, how to write the chemical formula. So today we are going to start with the topic periodic table. Okay, what do you mean by periodic table? How many elements are there in the periodic table? Yes?
Ma'am, 118.
Yes, 118. So those many elements are present today in the periodic table. Okay, so who was a scientist or who is called as a father of periodic table? Do you know, Shreya?
No, ma'am.
Okay, so Drimiti. Okay, Drimiti Mendeleev. Okay, Drimiti Mendeleev. So he is called as the father of periodic table. So this year you don't have periodic table. Okay, you don't have this chapter. The chapter has been deleted, but still you need to know some basic about this, because if you go for first year, okay, if you take science in first year, okay, you will be having periodic table. So there is a chapter completely on periodic table. So entire for PU1 and PU2, you will be studying in detail about periodic table. So we'll be just seeing some highlights about the periodic table of elements. Okay. So who was the father? So he Drimiti Mendeleev. Okay, Drimiti Mendeleev. He is called.
Ma'am, can you spell his name?
Dmitri. Okay. Mendeleev. Dmitri. So he is called as what? He is called as the father of periodic table. Okay. So the first detailed form of the periodic table was obtained by Mendeleev itself. It was first detailed periodic table was obtained by Mendeleev itself. So it was based on what? It was based on the mass number. Okay. But later, studies went on this, and later the modern periodic table was constructed, and it was constructed by Moseley. Okay, Moseley. So Moseley, he is called as the father of modern periodic table. So modern periodic table, the elements are arranged based on the number of atomic number. Okay, increasing order of their atomic number. So Mendeleev, what he did, he classified the elements based on the atomic mass. But later, so this was modified. So many scientists they started doing okay, so they started doing some research on this periodic table. So later Moseley, Moseley. So he is called as the father of modern periodic table. Okay. So here in your periodic table, so there are some natural elements and there are some synthetic or man-made elements. Okay, natural elements means what? So these are naturally occurred. Okay, so the elements there are some elements which occur naturally on Earth. So they are called as natural elements. For example, what? Oxygen. Okay, then nitrogen, then carbon. So these are some of the elements which are naturally occurring on the Earth. So these are called as what? These are called as natural elements. So what do you mean by synthetic or man-made elements? So synthetic element means nothing but it is a chemical element that does not occur naturally. Okay, it does not occur naturally on the Earth, but they are prepared artificially. So these are prepared by man. So they are prepared how? They are prepared artificially, and these are unstable. Okay, so the first, so these you can see here. Okay, after uranium, so these are some of the artificial. So later, okay, so these are some of the elements which are artificial. Okay, artificial. They are synthetic elements. Okay, so the first synthetic element which was made was technetium. Okay, you can see it here. Technetium. TECHNETIUM. Okay, I'll just show you. So it was the first okay, it was the first man-made element. Okay, technetium. So based on this, yesterday we have discussed about compounds. Okay, now why these elements were classified? Why the elements were classified? Okay, so you know there are n number of, so there are 118 now. At present, there are 118 elements. So without the classification of element, okay, if the elements were not classified into a periodic table, so it would be extremely difficult. Okay, it would be extremely difficult and time consuming to individually study okay, the chemistry of individual element. Okay, so individually if you want to study the each element, so it will be time consuming. So what scientists or researchers they did, they what they did, they arranged the elements or they classified the elements in the periodic table. Okay, so hence it was easier to simplify and systematic study of elements and their compounds. Okay, so because of this, they are classified into groups and periods. Okay, so here you can see what is a periodic table. So it is the arrangement of elements in a particular pattern. Okay, particular pattern based on the mass number. Mendeleev, what he did, he arranged the elements based on the mass number, and later scientists, after some research and all, they found that the modern periodic table, it is based that the elements are arranged according to the increasing atomic number. Okay, so how many elements are present? 118 elements. So to study or to okay, to study it in the simplified manner and systematic manner. So what they did, they classified the so they classified into groups and periods. Okay, so they classified them into groups and periods. So what? So there are 18 groups. You can see here. Okay, here you can see there are 18 groups. So these are called as groups. Just a second. Okay, so these are groups 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so there are 18 vertical, okay, there are 18 vertical columns. Okay, so these 18 vertical columns are called as what? They are called as groups. They are called as what? They are called as groups. And these 7 horizontal lines, okay, this horizontal lines 1, 2, 3, 4, 5, 6, 7. These 7 horizontal, they are called as rows. Okay, they are called as horizontal rows, and these are called as what? They are called as periods. What they are called as? Periods. Okay, so there are how many groups? 18 groups, 18 vertical column groups. Okay, vertical columns are called as what? They are called as groups. And how many periods are there? There are 7 periods. Okay, there are 7 periods. Okay, so there are 7 periods, 7 horizontal rows which are called as periods. So what were the early attempts? So as I discussed, so there were many scientists who were doing research on the periodic table. So the chemical and the physical characteristics, okay, of the scientists, what they noticed that so early attempts were known. So there were what they did first, the elements, they were arranged according to their atomic weights. Okay, so they tried to study their periodicity. What do you mean by periodicity? Periodicity means they are the properties of the elements. Okay, means how they are, how the elements are uh, in the increasing order, or okay, into the groups and all, how it is, how they are showing the similarities. Okay, how the similarities are shown. So early models of periodic table, so there were different scientists. So the first law was given by Dobriniers. Okay, Dobriniers triad. So what do you mean by Dobrinier? So Dobrinier means some okay, so Dobrinier, he gave the law of triads. Okay, what did Dobrinier do? So he arranged the elements in the group of three. Triads means what? Triads means in a group of three. So he arranged, so what he could see, that in the order of increasing atomic masses, okay, when you take the average of three, okay, so it will be equal to the center elements. Okay, so this was a Dobrinier triad rule. So like this, one more octave rules. Okay, the second scientist who gave, he was Newland. So he gave his octaves rule. So these two are important. So I'll just tell you about these two. So law of triads was given by Dobriniers, and second was Newland's law, that was octave law. What do you mean by octave law? So what he did, Newland, he arranged the elements in the order of increasing atomic mass. Okay, so after he, what he could see, that the first element and the eighth element, okay, the properties were similar. So you know the musical notes. Okay, sa re ga ma pa dha ni sa. So sa, so the first note and the seventh note, how it resembles the eighth note. The same way the law of octave was given. So he could see that after arranging, so from first and the eighth, it could show the similar properties. But this was applicable for only few elements. Okay, so this also failed. So further, Mosley came. So he gave the law of what, so modern periodic law was established. So in modern periodic law, what it says that the elements are arranged according to the increasing atomic number. Okay, atomic number. So when you arrange the elements in the increasing atomic number, you get how many groups? 18 groups and 7 periods. Okay, 7 periods. Now we'll see some of the okay, these elements you can see. So for your 10th, okay, so you need to remember first 20 elements. So you should be perfect with the first 20 elements. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, okay, potassium and calcium. So these are the first few elements, okay, first 20 elements which you need to remember. So for this, for your, okay, this time you have to remember 20, but in further higher classes, you need to remember the whole periodic table. Okay, so now first 20 elements are fine, first 20 or 25. So these are okay. Now we'll see what are these called. Okay, so group 1 and group 2. So group 1 and group 2, they are called as S block elements. So as the elements were classified, so they were classified into 4 groups. Okay, so 4 groups. So these A1 and 2, they are called as S block elements. So what they are called as? They are called as S block elements. Okay, so these 1 and 2 are called as S block elements. S block elements. Okay. Then this from 13, 14, 15, 16, 17, 18. So these are called as what? These are called as P block elements. What these are called as? P block elements. Okay, these are called as what? P block elements. Then from 3, okay, just shall change the color. So from 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these are called as D block elements. What these are called as? D block elements. These are called as D block elements. Okay, and here you can see this particular, so here, okay, this gap, here and this gap. So these are F block elements. So these, okay, these are placed at the bottom. So these are F block elements. So these are the what different groups. So these are the four groups. So S block elements, P block element, D block elements, and the F block elements. Now S block elements, these are okay, there are two groups, group 1 and group 2. Group 1 is called as alkali metals. Okay, they consist of alkali metals. What they consist of? They consist of alkali metals. And group 2, they consist of alkaline earth metals. What they consist of? Alkaline earth metals. Okay, then P block. So P block, so there are different this. So this is called as boron family because the first element is boron. So it is called as boron family. This is called as carbon family. So this is carbon family here. Then this is nitrogen family. Okay. So these are the group 15. Then group 16. This is oxygen family. Okay. Then these are fluorine, chlorine, bromine, iodine. These are called as what? These are called as halogens. What they are called as halogens. Okay, halogens. Then these are called as noble gases. So these are called as what? These are called as noble gases. Okay, these are called as noble gases. Then so these are D block elements. D block elements are also called as transition elements. What these are called as transition elements. Okay, these they are called as transition element. Then F block elements, the upper ones. So these are called as lanthanide series. Okay, these are called as lanthanide series, and these are called as actinide series. So this is the brief introduction about your periodic table. Okay, so this is about your periodic table. So now what are alkali metals? Why they are called as alkali metals? Okay, why they are called as alkali metals? So which are the elements present in alkali metals? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so these are called as alkali metals because okay, because why they are called as alkalis? Because they react with water. Okay, when they react with water, they form alkali. Okay, alkali. Okay, so the alkali metals, these are all shiny. They are having shiny. Okay, they have shiny. Then they are soft. So they are shiny. Okay, then they are soft. Okay, then they are highly reactive solids. So these are mostly solids and they are highly reactive because you know metals are highly reactive. Okay, metals, they are highly reactive. Okay, what are the properties of metals? Can you tell me what are the properties of metals? Okay, metals are shiny. Okay, metals are shiny. They are hard. They conduct electricity, heat and electricity. Why they conduct heat and electricity? Because they will be having free electrons. Okay, if they have free electrons, they can conduct heat and electricity. They are malleable and ductile. What do you mean by malleable? Malleability means they can be converted into sheets. Okay, malleability means they can be converted into sheet. Ductility means they can be converted into wires. Okay, they can be converted into wires. So they have shiny, they are soft, they are hard, they are good conductors of heat and electricity. Then heat and electricity, then they are what? They are sonorous. Okay, what do you mean by sonorous? What do you mean by sonorous? They okay, when you sonorous means what? Metals. Okay, metals, they have sound, right? They produce sound. Sonorous means what? They produce sound. They produce sound. So metals, they produce sound. So they are called as sonorous. Okay, so they are highly reactive. Okay, as they are metals, they are highly reactive. So and these alkali metals, they can easily give the electron. Okay, so they are called as electropositive metals. Why they are called as electropositive metals? They can easily give the outermost electron. Okay, so here the electrons are filled in s orbital. Okay, they are filled in s orbital, so they are called as s block elements. So here the electron can be easily given, so they are called as electropositive elements. The next is alkaline earth metals. Why they are called as alkaline earth metals? What are the elements present? beryllium, magnesium, calcium, strontium, barium, and radium. Okay, so these are alkaline earth metals. Because why the name is given as alkaline earth metals? Because their oxides are alkaline in nature. Okay, their oxides means what? When they react with oxygen, okay, they form oxides. So their oxides are alkaline in nature. So these are also same metals, right? So they are also shiny. Okay, the color is they are having silvery white. Then they are highly reactive metals. Okay, they are solids at standard temperature and pressure. And here in alkali metals, they lose one electron. Okay, because the outermost electronic configuration, they have +1. Here it will be +2. So they lose 2 electrons in this. So they form what? Mg +2, Ca +2, Sr +2, Ba +2. Okay, here lithium +1, sodium +1, potassium +1. Okay, so like this. So +1 means what? It has given one electron. Okay, so it forms electropositive elements. So they form what? Electropositive elements. So this is about alkali and alkaline earth metals. So what do you mean by alkali and alkaline metals? They come under the group called as S block element. Okay, then we'll study about halogens. So I'll just tell you about the important ones. Okay, alkali, alkaline earth metals, then halogens. So you know about halogens. So what are halogens? Fluorine, chlorine, bromine, iodine, acetine, and tercinine. Okay, so these are some of the halogens. So halogens, it is which group? It is in 17th group. Halogens are present where? They are present in 17th group. Okay. So they are generally represented as X. They are generally represented as X. Okay. X means they refer to halogens. So when you have a general reaction and you write X, then it is called as what? Then it is written as halogen. Okay, so then it is called as halogen. So halogen means what? HAL. Okay, halogen. Hal means salt. Okay, and gen means to produce. Okay, to produce. So these halogens, they are salt producing. Okay, they produce salt. They produce salt when they react with metals. Okay, when they react with metals, they produce salt. So they are called as salt producing. Halogens means salt producing. Okay, so these halogen, they will exist in all the three forms: solid, liquid, and gases. Okay, iodine. So iodine is solid in nature. Then acetine and iodine is solid in nature. Then bromine is liquid in nature, and fluorine and chlorine. Okay, these are gaseous in nature. Okay, so this is about the halogens. Now we'll talk about the noble gases. Okay, noble gases is also important. Noble gases. Noble gases. Okay, noble gases. So which are the elements? So this is present in which group? It is present in 18th group. Okay, 18th group. So which are the elements present in 18th group? Helium, neon, argon, krypton, xenon, okay, radon. So these are the radioactive. Okay, these are radioactive elements. They are also called as noble gases. Okay, so these are all odorless. So what is the properties of this element? So these are odorless. Odorless means what?
They don't have any smell.
Yes. Okay, odorless. Then they are colorless and they are monoatomic gas. Okay, monoatomic gas means what? They do not combine with each other. Means what? We have seen this atomicity, right? Argon Ar2, it does not form. It will be always in okay, in monoatomic form. So they are called as monoatomic. Okay, so these are monoatomic in nature. Okay, with very low chemical reactivity. They have very low chemical reactivity. Chemical reactivity is very low. Okay, so these are the properties. So here, so this is very important. So these are called as noble gases or inert gases. Okay, or they are called as rare gases. Okay, they are called as rare gases. So this is about your what? Halogens and noble gases. Now, what are metals? Okay, so these are metals from on the left side. Okay, left side of your periodic table. So these are called as metals, and on the right side of the periodic table, they are called as what they are called as non-metals. So you can see here, here it is there. Okay, basic metals. So blue color. Okay, if you see here, so some are basic metals means what? These are metals. Okay, these are all metals. And non-metals. So these are non-metals in purple in color. Okay, so these are all non-metals. So like this. Okay, not this. So these are non this, and blue color, these are semi okay, semi metals, or they're called as metalloids. Now what do you mean by metals? Metals I have discussed. Okay, metals means what? They are electropositive in nature. Okay, they will be having the tendency to give electrons. Okay, by losing electrons. Then what are non-metals then? Non-metals means what? It will be always, it will take electron. Okay, electronegative means what? It will have negative charge. Okay, so for example, if Cl, okay, Cl, if it takes one electron, it will become Cl minus. If sodium, if what it will do, it will give electron. Okay, 11 will be there. So to be more stable, okay, it will follow octet rule. So what it will do? It will be in +1 state. Okay, when it gives electrons, so this is called as electropositive. These are called as electronegative. So metals, non-metals are what? Non-metals are electronegative. Okay, so, and they as they gain electrons, so they are called as electronegative. Then what do you mean by metalloids? What do you mean by metalloids? And what are the properties of non-metals? Properties of non-metals. Okay, it will be ulta of metals. Okay, metals are what? They are hard. Non-metals are soft. Okay, they are soft. Metals are good conductors of heat and electricity. Non-metals are bad conductor of heat and electricity. Then these they form malleable. They show the property of malleability and ductility. Non-metals, they don't show the property of malleability and ductility. Okay. These are sonorous. Sonorous means what? Metals, they produce sound. Non-metals, they are not sonorous. They do not produce this. Okay. I've written here. You can just go through. Yes. So here you can see. Okay. So shiny surface, they are hard. Metals, the non-metals, they are dull. Okay. Because of the dullness, they do not shine. They are brittle and they break easily. Then they are bad conductor of heat and electricity. So neither they are malleable nor they are ductile. They are low melting point and boiling point, and they are electronegative in nature. So this is about the metals and non-metals. Yes, I had asked about metalloids. What do you mean by metalloids? What do you mean by metalloids? Metalloids means what? The elements will show the properties of both, okay, metals as well as non-metals. So when they show the properties both of metals as well as non-metals, then they're called as metalloids, or they are called as semi-metals. Semi-metals means what? They will show the properties of both non-metals, then they are called as what? They are called as semi-metals or metalloids. Okay. For example, you can see here boron, okay, then silicon, germanium, okay, arsenic, okay, then antimony, tellurium, and polonium. So these are the elements which show the property in between that of metals as well as non-metals. So when they show the properties of both metals as well as non-metals, then they're called as what? Then they are called as metalloids. Okay. So this is about the periodic table. Okay, this is about the periodic table. Okay, now how to feel the electrons? Okay, electronic configuration. How to write the electronic configuration? So you know what we discussed here. You can see that. You can see here. So the okay. So your hydrogen is having. So how the elements are arranged? Elements are arranged according to their increasing atomic number. Okay, so Okay, so I said elements are arranged according to their increasing atomic number. Okay, so you can see hydrogen, helium, okay, then lithium, beryllium. So you can see the atomic number. Atomic number is written at the top, right? Atomic number. You can see here how it is represented. Atomic number will be written at top. So how to fill the electrons? Okay, how to fill the electrons? So there is a principle called as Aufbau principle. Okay, Aufbau principle. So this is Aufbau principle. uh, what does Aufbau principle say? That the electrons are filled from lower energy level to higher energy level, from lower energy level to higher energy level. So Aufbau principle. Okay, what does Aufbau principle states? That the electrons are filled from lower energy level to higher energy level. So the filling of electrons takes place in this order. So what is a principle? It is Aufbau principle. So lower energy level. So 1s is the lowest energy level. Okay, then 1s, then it goes. So first the electron goes to 1s. Okay, then it goes to 2s, then the electron goes to 2p. Okay, then it goes to 3s, then it goes to 3p. Okay, then 4s, then 3d, 4p, 5s, so and so on. Okay, now you remember s. S means what? Like this. So s can accommodate maximum 2 electrons. Okay, it can accommodate maximum 2 electrons. S can accommodate maximum how many electrons? 2 electrons. Okay, maximum number of electrons accommodated by s orbital is 2. Then p. P will accommodate how many? P will accommodate 6. Okay, 1, 2, 3, 4, 5, 6. So 6 electron, maximum number of electron filled in a p block elements is 6. Then d block element, maximum number of electrons. Okay, they are 10. Okay, 10. And F block element, maximum number of elements 14. Okay, 14. Okay, 14. So,
Ma'am, can you tell the full form of SPDF?
no, they are like this only. S block, P block, D block, F block. They are how K, L, M, and shell are represented, right? So it is represented by the this only alphabets only. S, P, D, F. Okay, S means spherical shape. So the shape of this orbital will be spherical. So you'll be studying this in your higher classes. Okay. So S means it will have spherical shape. P block, P means it will have a dumbbell. Okay, dumbbell like this, dumbbell shape. D block means it will have a double dumbbell. Double dumbbell means like this shape. And this will have little TDS. Okay, so S block, D and F block. So they are just given as this only. Okay, S, P, D, F. No full form. So the maximum number of electrons are filled is 14. Okay. So for, just you need to remember how to fill the electrons for first 20. Okay, first 20. Now, for example, now hydrogen. Hydrogen, how many electrons are there? 1. So how you will fill it? How you will fill the this? It will be how? 1,
1s.
1. Okay, 1s, 1. Okay, next is what? Helium. Helium is 2. Helium, how will write? 1s, 2.
1s2.
Yes, 1s2. Now the s orbital is filled. Okay. Now for hydrogen helium. Okay. So we'll write for. Okay. Then we'll write for lithium, beryllium, boron, carbon. Okay. Just a second. For you also. You are right. So hydrogen. Okay. Hydrogen 1. So it will be 1s1. Okay, hydrogen, here I'll write hydrogen 1s1. Then helium, how many? 2. So it will be 1s2. Next is what? Lithium. Lithium is how many? 3. So how it will be?
1s2 1p.
Okay, you want that also to see, no? Okay, you know the first 20 elements?
Yes, ma'am.
Okay, I will go to the Aubert principle itself. After seeing that, you will be able to write it. Okay, we'll see there only. Yes, here. So helium, hydrogen, helium, lithium. Okay, hydrogen is 1, 2, 3. So this will be 1s1. This will be 1s2. Lithium 1s2 and 3 electrons are there. Then next, where it will go?
P.
No, from 1s, it will go to 2s. Then it will go to 2p, 3s. Then it will go to 3p, 4s. Then it will go to 3d, 4p, like this. So now it will be what? 1s, after 1s it is 2s. So it will be 2s, 1. Understood? So you're filling the electrons, so you know how many number of this are there. Okay, how many electrons will be filled in each orbital? S2 maximum, P 6, D 10, F 14. Okay, like that you are going to fill. Now lithium is over. Next is what? Beryllium is 4. So how it will be? 1s2, 2s2. Okay, then comes boron. Boron is what? 5. So it will be what? 1s2, 2s2, then 2p1, right? After 1s, 2s, it will go to what? 2p. 2p1, because how many electrons are there? 5. So 2, 2, and then next year. Then boron, after boron is carbon, 6. So how it will be? 1s2, 2s2,
2s2
then 2p.
2p2
Yes. Then comes nitrogen, 7. Okay. 1s2, 2s2, 2p.
3
Yes. Then oxygen is 8. 1s2, 2s2, 2p.
4
The maximum number of electrons accommodated by p is how many? 6. So till 6 electrons are filled, we are going to add in the same shell. Okay, p. Then next is what? Fluorine, 9. Okay, so it will be 1s2, 2s2, 2p.
5
Yes. Then is your neon. Okay, neon is 10. So it will be 1s2, 2s2, 2p, 6. Okay, now see, 1s over. Just a second. So after 1s, so 1s is done. Okay, we have filled in 1s, then come 2s, then 2p. Next is which shell? 3s. So neon, after neon is your sodium. Okay, it comes your sodium. So sodium is what? Sodium is 11.
1s2
1 is 2. Okay.
2s2
Yes.
2p6
Yes.
and 3s1.
Yes. Good. So like this you're going to write. Then sodium, next is magnesium. Magnesium is 12. Magnesium is 12. So it will be 1s2, 2s2, 2p6, 3s2.
2
Yes. Okay, after magnesium, what comes? Aluminium. Aluminium is 13. Okay, now see, 3s, the maximum number of electrons are 2. So it is already filled. Now, which orbital will go? 3p. Okay, now we'll go for 3p. So aluminium, just a second. Okay, now we'll take aluminium. So aluminium is 13. So aluminium 1s2, 2s2, 2p6, 3s2, and then 3p1.
3p1.
Yes, 3p1. Okay. Then after aluminum is your silicon. Silicon is 14. So go on filling same way. 1s2, 2s2, 2p6, 3s2 and 3p2.
2.
Okay. Then after silicon is phosphorus. 14. Sorry, phosphorus is 15. Okay. So same. 1s2, 2s2, 2p6, 3s2, 3p.
3.
Yes, 3. Okay. Then after phosphorus is what? Sulfur. 16. So it will be 1s2, 2s2, 2p6, 3s2, 3p4. Okay. Then after sulfur,
Chlorine.
yes, chlorine. Okay. So I'll just clear this now. Chlorine 17. Okay. So chlorine 1s2, 2s2, 2p6, 3s2, 3p. 5. Right. Then argon 18. 1s2, 2s2, 2p6, 3s2, 3p6.
6.
Yes. Then next is what? Potassium 19. So 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, which comes? 4s.
4s1.
Yes, 4s1. Okay. Then after potassium, calcium 20. So 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2.
2.
Understood? So
Yes, ma'am.
yes, first 20 elements you need to know the electronic configuration. Okay, so this is called as Aufbau principle. So this is called as Aufbau principle. So we'll just, so if you have any doubts, you can ask. So I've completed my session. So if you have any doubts regarding periodic table, you can just ask me, or in the previous this also you can just ask.
No, ma'am, I don't have any doubts.
So this is about periodic table. Okay, so periodic table chapter is not there, but you need to know the some brief in this idea about the periodic table. So this is about periodic table. So what is modern periodic law? Okay, so who was the father of this periodic table? Who is called as the father of periodic table? Okay, what are metals? What are non-metals? Okay, what are metalloids? Then what are which are the different groups? So they are categorized into 4 groups: S block, P block, D and F block. So S block element, what they consist of? S block consists of alkali and alkaline earth metals. P block consists of boron family, carbon family, nitrogen, oxygen family, halogens, and your noble gases. Then D block elements, they are also called as transition elements. Okay. Okay, these are the transition elements from group 3 to group 12. Then F block elements, okay, they are called as inner transition elements. They are called as inner transition elements. Okay, you can see here they have a special. So this, okay, so this is called as inner transition elements. Okay, these are separately taken here. Okay, at the bottom. Okay, so inner transition elements. So lanthanide series, the upper one is in lanthanide series, the down one is actinide series. Okay, so these are radioactive metals. So these are radioactive elements. So this is about the periodic table. Then, so this only. Okay, what are the properties? Okay, filling up. Then the electronic configuration. So this is okay. So these are the points you need to remember. So if you have any doubts, you can ask, or else we'll stop the session. Okay. Electronic configuration is clear, right?
Yes, ma'am.
Okay. So the filling of the electrons, it takes place according to Aufbau principle. from lower energy level to higher energy level. Okay. So this is about Aufbau principle. Okay, then we'll meet in the next class. Thank you.
Thank you, ma'am.